let's see what is optimization. When we say optimization, as we know, mathematical modeling helps us to understand the real life situation and provides the optimum solutions to different problems. The theory of maxima and minima is used to optimize various real life situations, such as maximizing the space by designers, minimizing the cost by manufacturers, or in simple words, maximizing or minimizing the area, cost, profit, volume in different real life situations. Now, we should keep some steps in mind in order to address the optimization problems effectively. There are few steps. Step number one, read the problem and understand it well. Number two, draw the diagram, a clear diagram, label the known and unknown quantities. Step number three, set up the mathematical equation with the quantity to be optimized as a subject. Step number four, use mathematics to make the formed equation in the previous step in one variable. Set up the constraints. Step number five, find the derivative and equate it to 0. To find the stationary points, we can say where the gradient is 0, use the first or second derivative test or sign diagram to confirm the optimum solution, and check at the endpoints of the constraints also. Step number 7, do not forget to write the answer as per the question in words. Now I have a very nice TOK question here for the IB students, for IBDP students. As we know, mathematicians and historians have to be explanatory to explain their world. Does they use the same word? Explanation means, is the word explanation means same for both historians and mathematicians? Comment on your understanding on this TOK statement. Let's take the following example to understand these concepts of change in modeling well. Example number 1 is taken. It's a question from Hess Mathematics, especially at 1 p.m. ship A leaves port P. It sails in the direction 30 degree east of north at 12 km per hour. At the same time, ship B is 100 km due east of P and is sailing at 8 km per hour towards P. First part, show that the distance between the two ships is given by dt is equal to square root of 340 square minus 2800 t plus 10,000 km, where t is the number of hours after 1 p.m. Find the minimum value of d square for all t greater than or equal to 0. At what time to the nearest minute are the ships closest? Let's look at the answer. Solution. Let's draw the diagram first. You can see the diagram on the right hand side. Port P, ship B, ship A, north, east, west, south. Ship B is at 100 km from P, and ship A is traveling at 30 degree in the direction of 30 degree at 12 km per hour. Ship B is traveling 8 km per hour towards P, and is 100 km from port. Now the diagram is not to scale. So we know that this speed is equal to distance upon time. So therefore, if t is the time taken by the both ships, then the time will be equal to distance upon speed. And distance traveled by ship A after t hours is 12 t km, and distance traveled by ship B after t hours will be 100 minus 80 km. Now, in triangle APB, angle APB is 60 degree. Angle APB is 90 minus 30, that is 60 degree. In triangle PAB, we can apply the cosine rule and find the distance dt Square root of 100 minus 80 whole square plus 12t whole square minus 2 times 100 minus 80 into 12 into t into cos of 60 degree. That's the distance formula. That's the cosine formula, cosine rule. Therefore, simplify it and we'll get the required equation. 340 square root of 340 square minus 2800 t plus 10,000 kilometer. That is the distance equation between the ship A and B. Now the second part is find the minimum value of d square for all t square for all t greater than or equal to 0. So for that, what we'll do? We'll differentiate. First we need to square it, and that is 340 square minus 2800t plus 10,000. Then differentiate, that is 680 minus 20. Then equate the derivative to 0 and find the value t is equal to 2800 divided by 600. The minimum value. Therefore, double derivative is positive, so that means t is equal to 2800 divided by 600. It gives the minimum value of d square t. Therefore, we can find what is that minimum value, that is 3552.63 kilometer, and rounding to three significant figures, 3550 kilometer. Now the last part or C part is at what time to the nearest minute are the ships closest. When t is equal to 2800 by 608, approximately 4.605 hours, means 4 hours 36 minutes. We know that t is the number of hours after 1 p.m. So therefore the ships are closest to each other at 5:36 p.m. Let's look at another question. Another example, an IBDP style question. Hugh can row a boat at 3 km per hour. He is currently at point P on the shore of a lake 2 km in radius. He will row to point Q, then walk around the shore from point Q to R, which is opposite to P. Now what we want to find? Show that PQ, the distance PQ is equal to 4 cos theta kilometer. PQ, this PQ. And B part, show that the time taken for Hugh is given by total time taken 4 by 3 cos theta plus 2 by 3 theta hours for 0 to pi by 2. Theta is between 0 to pi by 2. And the C part is find theta such that dt by d theta is equal to 0 for 0 to pi by 2. And D part is draw the sign diagram for gradient function. Then E part is what route should Hugh take to travel from P to R in the longest time or the shortest time. So let's look at the solution. First part. Let's see the diagram. Let's draw the diagram. Join QR and form triangle PQR. So as we know, the diameter PR and angle PQR is the angle in the semicircle. Therefore, PQR is equal to 90 degree. So in triangle PQR, we can apply the T ratios, and PQ is PR cos theta and PR is 4. So therefore, PQ is equal to 4 cos theta because PR is the diameter. Now look at the diagram again. Join the center and point Q and R and point Q. So we can calculate angle Q at the angle at the center, because angle P, we should say this point center C, PCQ will be pi minus 2 theta. So this angle will be 2 theta, means QCR will be 2 theta. We know speed is distance upon time. So time is distance upon speed. So we can form the equation. Time from P to Q is 4 cos theta by 3, and distance from Q to R is the arc length QR when he is walking along this Q to R. That's arc length. So the angle is 2 theta and the radius is 2. So therefore, theta into radius, angle into radius is the arc length QR, that is 4 theta. So therefore, time taken from Q to R is 4 theta by 6, that is 2 by 3 theta. So therefore, total time will be, add those two times from P to Q and Q to R, that is 4 by 3 cos theta plus 2 by 3 theta. Okay. Now find the derivative. There is a negative 4 by 3 negative sine theta plus 2 by 3 equate to 0, and we'll get sine theta is equal to 1 by 2 between 0 to pi by 2, and theta is pi by 6, because in first quadrant the reference angle is pi by 6, so first quadrant theta is equal to pi by 6. Sine diagram. If you look at the sine diagram, on the left side of pi by 6, you may consider any smaller value on the left side and any closer value on the right side, and substitute in the gradient function. You'll find that the gradient is positive on the left side and negative on the right side of pi by 6. E part. From P to Q, theta is equal to pi by 6 gives the longest time, because we wanted to calculate the longest time. And if we walk directly from P to R, that will be the shortest time. Thank you.